Hello everyone, I'm here again. So here is my graduate student Mausam, and Mausam did work when he took my CS 550, that class last semester, and it's about container technologies. I think Syed also did, was in the same group, right?
Right.
Yeah. So now let's hear from Mausam what he has to say. Yeah.
Thank you. Hello everyone. My name is Mausam Parajuli, and today I'm going to present on exploring performance evaluation of Docker and LXC container. And we're going to see if they are good for IoT and then cloud environment. And this paper and study was carried out in Dr. Ghosh's class along with Mr. Syed. And just a disclaimer, there's going to be a lot of information in next 10 minutes, so buckle up. But I'll try to keep it as simple as possible so that everyone here understands what I'm talking about. So, a container. What's the first thing that comes in your mind when you hear the word container? Anyone?
A way to move objects.
Right, it's a way to move objects. Just like that in computing world, a container provides a platform where you can isolate and package applications. And those applications can be moved around easily. That's what makes it portable. And then it can be easily moved around and shared between different platforms, which makes development and deployment a lot more efficient. Why do we use containers? There's a lot of reasons, and some of the major reasons are it is highly scalable. That means whatever applications we're building using container, we can easily scale up and down depending on user requirement. And it is also cost effective because it saves a lot of money. And some of the famous containers are Docker and LXC. LXC stands for Linux container, and these two containers were the best for these study. Now, before container, we used to use traditional virtualization, which was the idea of using virtual machine. So what is a virtual machine? A virtual machine is nothing but computer within a computer. So for example, I have this Windows computer running right here. And then if I also want to use Mac operating system or another operating system, let's say Linux, then I will have to use this concept of virtual machine. And to do that, what I have to do is I have to install a hypervisor. Hypervisor is just a fancy word for a software that will allow you to use multiple virtual machines within a computer. So basically, inside this computer, I will download another software, and on the top of that software, I will download another operating system. And since there are a lot of process of installing things, this can cause performance overhead. And this is where container comes to play. Because with containers, you can run them directly on the top of whatever operating system that you're using. For example, I'm using this Windows operating system, right? So without having to install hypervisor, I can run container directly on the top of this machine. And that just causes very minimum performance overhead. And this is why we prefer containers, because they are very lightweight. Now, what are the use cases of containers? One of the biggest use cases of container is IoT, which stands for Internet of Things. And IoT are, just like in the picture, these are any smart devices that are connected all around the world, which we use to exchange data and then act on this data. A simple example would be your cellular device that you use on a regular basis. That's an example of IoT device. You can use your phone to control different smart devices at your home. For example, some smart speaker like Alexa or Google Assistant. You can use your phone to control what music you want to play, what volume you want to set up, and that's an example of IoT device. Another example of IoT device is this thing right here. Believe me, it's a computer right here, and it has everything in it that is necessary to run a computer. It's called Raspberry Pi, and it's a single board computer. And this is another example of IoT device. And this is a kind of device that we use on our research lab here at JSU when we want to do different performance evaluation on the level of container. And there are billions of IoT devices all around the world, and it comes with different challenges. So some of the challenges are the management. There are a lot of devices, and we have to manage all those devices. There could be connectivity issues, and most importantly, there could be security issues because these devices are directly connected to the network. There are always hackers, trying to get to your information. So we need to address these issues. And containers, thank God we have containers that can address, because containers again are lightweight, which means we can have as many applications as possible within a container, and this improves the resource utilization. And also, these application within container can be isolated. So for example, if I want to use one specific application inside a container, I can do that. I can do that without having to affect any other applications within that container. And it improves security and stability. And it also ensures compatibility because containers can be moved from one platform to another platform so easily. Another big use case of container is cloud environment, and cloud is nothing but online storage where we can store data. For example, I'm using a cloud environment provided by JSU for free, OneDrive right now. I'm using OneDrive to access my PowerPoint presentation, and then that's how I'm showing my presentation there. That's an example of cloud environment, right? And then we can also use containers in these cloud environments because they are flexible, they're accessible because we can access those data from anywhere around the world, and as long as you have the internet, and they are also very cost effective. And some of the famous public container services are AWS, provided by Amazon, and then Google Compute Engine, provided by Google. Now, our study was based on reading a lot of papers, what other researchers have done in the past based on these topics, and some of the key points from those studies are performance difference in container and native computer are negligible. And this is a very important finding because this is what makes containers so amazing. So let me explain what do I mean by performance difference in container and native computer are negligible. So if I'm using this computer right here, it's a Windows computer, and let's say I do a benchmarking on the level of CPU. For example, I'm asking my CPU to do some basic computation, maybe to give me a value of pi or some other computation, and I do some benchmarking to see how many millions of instructions the CPU is sending every second. And that's some kind of benchmarking, and I get some kind of result, right? And then now that's my native computer. I'm doing that performance on the level of my native computer. Now I install container inside this machine, and then I do the same benchmarking inside that container. Now I'm trying to get the performance of that CPU while running a container. And surprisingly, you would expect when you are running an application, it will slow down your CPU performance, but surprisingly with the container, they are so lightweight, the performance difference is actually very negligible. In most cases, it's less than 10%, which is an amazing thing in computing world. And it is also very different to traditional virtualization because when you use virtual machine, you actually have to install hypervisor, and then you will have to have your guest operating system, then run the performance test, which in some cases, the performance difference would be more than 50%, and which is crazy because we do not want anything to be more than 50% in computing world. That's why containers are so important because they are lightweight and their performance is just amazing and it's more efficient. And it causes minimum overhead. And they are also better approach when it comes to IoT scenarios and cloud computing. Now, some of the key observations from our paper are, of course, container technologies are promising for a cloud environment and IoT scenario because of all the reasons I mentioned before. And containers are also best options to migrate an embedded system to the cloud. So what do I mean by embedded system? Embedded system is nothing but a bunch of computers that are connected over a network where we can share and data between all those different devices connected on that network. For example, all the computers that we have in our research lab in JSU are a perfect example of embedded system because we have a private network that connects all those computers and we exchange data easily from to and fro those devices. And containers also allow us to build, deploy, and manage software for an endpoint IoT device. And we do find a very interesting finding in one of the paper which says traditional virtualization is still crucial to cloud deployment. And this is very important because I think this opens a gate for future researchers because it looks like there's a need for a deeper study because we're not sure why still in some cases traditional virtualization is better than container. And a further study is of course needed in this field. Now, so to conclude this presentation, I talked about the use cases of container technologies, reviews previously work done on this field, and then also present our finding. Now the biggest question is there a need for a future work? And a simple answer is yes. And if you, when I talk about all this container, I'm talking about containers in general. And then when we read all the papers, all the work done by researchers in the past, these are all general study. Now here, what am I thinking is we haven't done any specific study. For example, is Docker better than LXC when it comes to cloud environment or IoT devices? Or or LXC could be better than Docker. Or they could be even a better container. For example, Podman. This is an emerging container. Just like Superman and Batman, this could be a superhero when it comes to container. So maybe Podman is better than LXC and Docker. So that would be my future research. Try to find a performance evaluation of all these container and figure out which could be a better for cloud environment and IoT devices. So in the end, of course, I would like to thank Dr. Ghosh and his fledgling research lab, and I would also like to thank our MCIS department, College of Science and Mathematics, and the entire JSU family for providing this amazing platform for a student like us to showcase our study. And most importantly, thank you everyone who is here to support this beautiful event. And here are some of the references that I used for this study. And now it's fun time, the floor is open for questions. Yes.
So you're saying it's a lot of weight than a virtual machine, which is more sandbox. Got a question about that. Is it also more secure? And when the yeah, let me just ask that right now.
Right. So containers are more secure than virtual machine for sure, but containers also do come with a lot of challenges, and security is one of them. And especially so, this is how container works. Whenever we have containers, we start with a base image. So we'll need to get, so base image is where you actually start your application. So it's just a basic foundation. And whenever we download those base images, we gotta make sure we get that image from a trusted source. You cannot just download it from anywhere. That might cause security issue. But it has improved security compared to virtual machine because now in container, those applications are actually isolated. So we can specifically focus on one single applications and without having to worry about other applications within that container.
So let me ask one more thing. Was that
Yeah, sure.
because virtual machine and this is a little bit different. Is the lag time any different from reading from the actual PC to the to other device where you're at? Is the lag time any different than a virtual machine because
Right.
of security issues?
Okay, so in general, whenever you are, so virtual machine will be more secure than the regular PC. Of course, it comes with better security, again, because you can manage application better. But containers are even better because we can manage things even in a better way, if that makes sense.
Oh, that makes perfect sense.
Right,
Thank you.
no problem.
Any other questions for our speaker?
Yes,
So other than security, what are some other challenges that you can face using containers?
right. Okay, that's an amazing question. So there could be other issues while using container. For example, of course, the networking issues, right? We're connecting all these things to a network. And of course, if you do not have something like firewall on your computer, that could be a big issue, and hackers are always trying to get to your information. And so that's something you gotta use firewall and other security stuff to make sure your network is secure. And of course, there could be issues with data. For example, let's say when you're dealing with container, you're working on the top of host computer. So you want to make sure those data within the container are stored and contained inside the container, not to your host computer, because anyone who has access to your host computer can easily get those data, and that information can be leaked. So you gotta make sure your data is secure. And also, like I was saying before, you have to be absolutely sure from where you are downloading your ISO emails or the emails that you're using for your application. You cannot just be downloading from anywhere. So those are some issues that might occur when using containers. That was an excellent question. Thank you.
We can have one more question.
All right.
All right. If no more question, let's thank our speaker.
All right. Thank you so much. I'm sure, sign up.